All right, first I wanted to say thank you for everyone coming out today. Welcome. Hope you guys are excited to learn some fascinating information about the solar eclipse that is going to be on August 21st. I also wanted to make sure that I mentioned that at the circulation desk, we have some eclipse glasses. They are $2 a piece. If you would like to purchase a pair at the end of the event, you can do so. But yeah, once again, thank you so much, everybody, coming out today. And with that, I would like to introduce and turn things over to Mr. Mitt Landrum. Thank you.
Thank you all for coming out. Everybody hear me okay? Okay. All right, so we're going to talk about the solar eclipse. How many of you have seen a total solar eclipse? Anybody here? You've seen one? How long ago was it? A long time ago? Yeah, I saw one in 1970. And Moncks Corner, South Carolina. I went over there to see the eclipse, and it really was awesome. And so I'm going to tell you what that was like. And also, we're going to talk about the one that is coming through Missouri today. Let's talk first about what an eclipse is. Okay, there are two kinds of eclipse that we see generally. There's lunar eclipses where the moon passes through the shadow of the earth. We see those every 6 months. Every 6 months, it'll line up. The Earth's shadow is a pretty big place, and so the moon will hit part of it when it goes past. There are about 2 solar eclipses every year too, but some years there are more, some years there are fewer of them. And it's much harder for the moon to line up and have its shadow cast on the Earth. Okay, and the reason is that the moon is not lined up with the plane of the Earth's equator. If it was, we'd have a total solar eclipse every month. Right. Sooner or later, the moon would come around. When it was a new moon, it would pass right in front of the sun. There'd be a solar eclipse right on the equator. Places like Venezuela, we have a big eclipse industry going down there. But the problem is that the moon's orbit is tilted 5 degrees to the plane of our equator. So most of the time, when the moon passes as a new moon around on the sun side, it passes over or below the sun, and the shadow misses us all together. And you can kind of see this. I'm going to draw a little diagram. I like drawing. Okay, so the eclipse diagrams that you see, here's a typical one. This is the best I could find on the internet. And if you look at the eclipse diagram, the scale is so poor you really can't see what's going on, and so they kind of mislead you a little bit. So let's make the Earth, put the Earth right here. And we're looking down from the North Pole. So we're up above the North Pole, looking down on top of the Earth. Okay, that's our position. So the Earth's rotation in this direction. It rotates around so that as the sun is over here, we'll see it rise in the east. And things that are to the west over here will gradually come around later. Okay, so this is the rotation of the Earth. All right, so if this is 2 inches here, that's the size of our Earth, and the moon is 5 feet away, and it's 1/4 inch. The Earth is 8,000 miles in diameter. The moon is 240,000 miles away from the Earth. That's 30 times the diameter of the Earth. So on this scale, you can see the moon's orbit is a huge circle. Okay, how big that is. And you can also see that the shadow is a long, skinny thing that travels through 250,000 miles of space. And so it's much harder to get this geometry to line up. Okay? But it does happen about twice a year, on the average. And when it does happen, most of the time it's over the oceans. And so eclipses that are on land in populated areas are really fairly rare. The Earth's surface is 3/4 water, and so that's why the shadow of the moon, generally speaking, is over there. So from the Earth, the moon, its angular size is 1/2 degree. So that means if you start from horizon here to straight up overhead, which is called the zenith, say 90 degrees to that arc, the moon is 1/2 of 1 degree in size. It always surprises people because the full moon looks pretty big, but it's actually just 1/2 degree. On this scale here, the sun is a ball 166 feet in diameter, and it's 2,000 feet away down that direction. So it's almost a half mile. Okay? And the sun from the Earth also is a half a degree in size. And so the moon will exactly cover the sun. But now sometimes it doesn't always work out that way because the moon's orbit around the Earth is not a perfect circle. It's actually slightly elliptical. So it's a little farther here on one time than another. So if the moon and the sun line up, when the moon is far away from the Earth, the size of the moon will be small. And it won't fully cover the sun. And so there are types of eclipses called annular eclipses. Here's one here. Okay? And so you can have the shadow pass directly over you, but it won't fully cover the surface of the sun. You won't see the corona, which is the thing everybody wants to see. Okay? And conversely, if the eclipse happens when the moon is close to the Earth, it'll be very large. And so the moon's shadow will be larger passing across the Earth. And the time that you're in the moon shadow, which is called the time of totality, will be very long. And those are really good eclipses because you get to see the corona for a long, long time. The longest one recently was over 6 minutes long. 6 minutes, and I think it was in 2009 in China or something like that. Then it went out over the Pacific. Our path of totality here, if you're under the center of the path of totality, the eclipse that we're going to have is going to last about 2 minutes and 40 seconds right around here, which is a pretty decent amount of time. Okay, so that's the amount of time, and everybody that really is into eclipses, that's what they're really after. And so here at MAC, the total eclipse totality time is going to be about 2 minutes and 20 seconds because we're not directly under the very center of the path going across the Earth. Okay? We're a little bit off to the side. And so the length of the totality is a little bit less. It's still pretty good. Okay? All right, so what is going to happen then? Let's just take the eclipse step by step through. So let's say you get to a site. We're going to discuss where and when in just a few minutes. But what will happen? Well, from right here, if you go to MAC here, say you're at MAC, the moon will start to cover the sun about 10 minutes till 12 on the 21st. And so what you'll see that here's the disk of the sun, and if you use your eclipse glasses, you'll see a tiny little notch just show up here. That this is the west side of the sun. You'll see a tiny little notch as the moon starts to cover over the sun. Okay? And it's going to keep eating into that as time passes. And you'll see this get bigger, bigger, and bigger, and bigger. And finally, it'll be just a thin, narrow crescent. And all the time that that's happening, it will become more and more like twilight. It'll become darker and darker and darker, but still seem like daylight. Okay? And so this will gradually become a crescent. And one of the interesting things to look at with a crescent, so here's a picture of what that looked like when it's about halfway to totality. And with your eclipse glasses, you'll be able to look directly at it. Okay? If you're in a wooded area, you'll see this. And if you look here, see how these are all images of the sun that are like little crescents. Okay? This is a famous kind of a fact about eclipses. What happens is the shadow, the tree leaves will kind of almost cover over each other. They'll leave tiny little holes where the sunlight comes through, and each one of those holes acts like a pinhole camera. And so it reveals an image of the sun as a crescent. When you see dappled shadows in your driveway or something, the trees, those are actually images of the sun. They're all circles. If you'll notice, it's a whole bunch of little circles. Well, those are actually images of the whole circle of the sun. And during an eclipse of the sun, you'll see these things start to happen. So that will happen. We won't be very far from totality when you see that kind of thing happen. So the sun will shrink to a really thin crescent. And then just before the sun is completely covered by the moon, you'll see an effect called Baily's beads. Okay? And so Baily's beads is another famous eclipse feature. Man, I like this. Now this is the way a whiteboard ought to work. You know, one of these things in Sunday school, you cannot get this stuff off. So, now what Baily's beads is here's the moon here, and it's almost covered the sun, and there's a thin little crescent. But the moon isn't a perfect billiard ball-like thing. It's got mountains on it. And so where there's a little valley here at the edge of the moon's limb, the sunlight will pour through it. And so it'll look like these spangles right around the edge of the darkness. Those are called Baily's Beads. And they don't last very long because the moon actually is moving right along in its orbit, and they just start to blink out, and you're left with one brilliant one usually, and that's called the diamond ring. And when you get to the diamond ring, you're just a few seconds away from totality. The diamond ring will last just for a second, and then bang, you'll go into totality. And that's really what you travel up a distance or whatever you did to get to see a total solar eclipse. When you get to totality, you'll see what happens. Totality will happen suddenly, okay? The tiniest little bit, like this diamond ring of the solar surface showing around the edge of the moon is enough to make you think it's daytime, even though it's gotten pretty dark. You'll think, well, it's still day. And then just like that, it'll be night, okay? Because you'll pass into the shadow of the moon. And at nighttime, a lot of crazy things happen. Well, the animals are totally confused. The birds will start chirping, they'll start flying back and forth overhead because the nighttime birds are thinking, wait a minute, I gotta get up. Whoa, that was a short night. And the daytime birds are thinking just the opposite. I gotta get to my nest. And so, oftentimes you'll see things like that, especially around here in Missouri, I would think. Now, once totality happens, that'll be around 1:18 p.m. on August the 21st. You need to take your eclipse glasses off. Take them off. There have been people that have missed the total eclipse completely because they left their glasses on looking at it and couldn't see anything. Take them off. Once the moon covers the sun, you need to be able to see this with the naked eye. Okay? What you'll see is the solar corona. Okay? And this is and here's a typical picture of a solar eclipse, and you look at that thing and you say, well, it's a big whoop. There's a black spot, and you've got a glowing cloud around it. But when you see the actual solar corona, the atmosphere of the sun, it is just, it's completely, pictures cannot do that thing justice. I mean, how many of you have taken pictures of a sunset and you look at them, even with a really good digital camera, they just don't have what that sunset had. And it's the same thing with the solar corona. It is the sun's outer atmosphere. It's made out of plasma. It's not actually a gas made out of molecules. It's 10 million degrees Fahrenheit. That's how hot that thing is. It extends millions of miles out into space. And at the very edges of it, that's where the solar wind comes from. Okay? It's about as bright as a full moon, and it is an iridescent mother of pearl color. Okay? It's indescribable to exactly get the right color on that thing. But plasma, which is what this is made out of, is not a molecule. It's too hot. And so atoms are divided up into their elemental particles. So it's a jumble of electrons and protons and neutrons, all out there banging around into each other at these super high temperatures. And so there's not actually an atom in this thing. It's plasma. Okay? And that's what you're looking at. And the color of it is that's the reason why people are drawn to solar eclipses, just to see this natural phenomenon. And the only way you're going to see it from Earth is when the moon passes in front of the sun. Now, this is a typical corona from a time when the sun is quiet, when there are not very many sunspots. Okay, every 11 years the sun cycles through lots of sunspots, then few, then back to more. And this is a view of a corona when it's active, when there are a lot of sunspots. We are about halfway between cycles. And, the last time that 3 or 4 years ago when the sunspots were at a maximum, we didn't have very many of them. So we may look more like this than like this when you see it. Okay? The other thing that you'll see right around the edges, you can kind of see it in this a little bit. This little pink thing right here. Okay? You'll see little loops, and there are just these glowing orange pink loops, and those are solar prominences that you'll see around the edge of the sun. The sun's surface is not actually a surface at all. The sun is a ball of gas. If you try to step out onto it with some kind of ceramic uniform, so you can walk around up there, you'd fall right into it. What we see as the sun is simply the place at which this ball of gas becomes opaque. The corona is transparent, so we look through to the level of the sun where the gas is opaque. We can't see any farther than that. So it looks like a surface, but it's really not. But it's turbulent, as you can imagine. The surface of the sun is about 10,000 degrees Fahrenheit. And the solar corona around it is 10 million degrees. Okay. And you'll see storms. A storm will cause a bunch of gas to loop up off of here and then drop back in. And you'll see these little filaments, okay? And you can see them around the edge of the moon. They'll stick out far enough from the sun so that you can see these hot little filaments. And when you look at it, you'll see these little pink things all around the edge. And those are storms that are going on from the sun at that time. So while we're talking about this, this is one of the great mysteries of the sun right here. And that is, how can you have a $10 million degree bunch of gas sitting on top of a 10,000 degree surface? That's like taking a pan full of water and setting it on your stove and you don't turn it on, the water boils. Okay? How does that happen? That is not, they're still working on that. Okay? They have theories, but this has been known for decades and they still haven't figured out exactly how it is that the solar corona is so hot and the surface of the sun is not. Okay? So this is what you'll see when you finally get to totality, and we get 220 to 240, depending on where you go, time to be in the moon's shadow and see that. And that may be the only time in your life that you're going to get to see this stuff. So I always encourage people a couple of things. Be sure you take your glasses off. Don't take pictures. And the reason is that you'll spend more time fiddling around, looking through the camera, and you want to look directly at this thing. There's going to be a bajillion photographs of this thing taken by professionals. I can guarantee you this is going to be one of the most photographed events probably, in our country for decades. People taking pictures of it. So just look at it with your eye when you get the chance to do that. The temperature will drop once the shadow comes. The temperature may fall 30 degrees or so because we're at nighttime. Okay? If you look around the horizon, you'll see that it looks like sunset all the way around the horizon. The edge of the moon's shadow, I'll show you a map here in a second, but you're actually, if you get to the center of the moon's shadow, which is up near DeSoto, for us, is one place it'll be. It's many miles off to where the edge of the shadow is, where daytime is. You'd have to get in your car and drive 30, 40 miles to get to daytime, okay? And so that's far enough away that daytime doesn't leak into this too much, and it looks like nighttime. But it will look like you'll see a reddish tinge all the way around the horizon. Okay. Once you look at the corona, you'll also see things behind you. You'll see the nighttime stars behind the sun. It's nighttime. Okay. The corona, the solar corona, is about as bright as the full moon. It's a millionth as bright as the surface of the sun. So they don't show the corona here, but here's the way it will be. There'll be the moon blocking off the sun. And then you'll see Regulus, which is the brightest star in the constellation Leo. So the sun is in Leo, right? All of you astrology fans? Right there. And so here's Regulus, here's the coat hanger loop, here's the tail of the lion here. You'll see 4 planets. There's Jupiter down here, it'll be pretty bright. It's down in Virgo. Mercury, which is always difficult to see, it'll be a little bit down here about, what is that, 7, 8 o'clock position from the sun. Okay. It'll look kind of reddish. Mars on the other side here. Okay. And then there's Venus over here. The rest of the planets around on the other side, so we won't see them. We're looking past the sun at Mars. It's across its orbit from us. Okay, so we're looking past the sun and 35 million miles or so beyond to where, no, I guess it's more than that. It's 35 plus, it's 135 million miles all over there. And then you'll see other stars around it. So you'll be able to see the nighttime sky for 2 minutes and 20 seconds, at 1 p.m. on August. Okay, so here's where it's going to go. I tried to blow this thing up and it just not working out too well. So here's the size of the solar shadow here. And the red line here is the very center. This is where it's 2 minutes and 40 seconds in totality. And so this is DeSoto right here, this little dot. So you can see it goes just north of DeSoto, just south of Festus. Farmington, Bonne Terre, we're all in it. Farmington is down here, and here's 2 minutes of duration. Here's 2:30 here, so Farmington, let's see, Bonne Terre is 2:30, Farmington's like 2:10, 2:05, something like that. So The farther away you get from this red line, the shorter and shorter the duration of the totality is. You may want to think about that. Then it goes north of Perryville and on across, and it goes on down here off of this map here to Carbondale over in Illinois. Now, one interesting thing is there's going to be another total solar eclipse come through here in 2024, 7 years from now. And the only place in the country that's going to also be under the path of totality is Carbondale, Illinois. So if we don't make it to this one, or if the clouds stop us, or whatever, the weather's bad, we got another shot at this thing if we can just make it another 7 years. Okay? But anyway, that's the path of this one. And so after about 2.5 minutes, the diamond ring will appear again on the other side of the sun. The sunlight will peek through the first valley, and then it finds the brilliant piece of light will show up, and suddenly it's daytime again. The corona will disappear just like that. As soon as the tiniest bit of the surface of the sun shows around the edge of the moon, the corona disappears, and the eclipse is over. Okay? And everybody starts packing up all their stuff, jump in the car, and they're out of there. So, in terms of a tourism event, this is what we call a square wave. We get it, and then it's finished. So, the daylight will be back, the birds will get confused again and come back out. It'll start warming up, and the crescent will grow and grow and grow, and then about an hour and a half or so afterwards, the sun will get back to its full disk, and the moon will be off, headed around the Earth again. Okay, so let's talk about some do's and don'ts here. You want to get to a place, first of all, where you can see the eclipse, so be checking the weather for a couple of days ahead of time and see what it looks like. And I actually have some info on that. Here we go. All right, so this is the percent frequency that it's overcast or broken clouds. These are from airport reports here. And so for some reason, they know Farmington could have given them this, but they didn't study us. So they have like Spirit of St. Louis, pretty good. It's clear on, this is in August, I think, for the whole month of August. About 15% of the time. A few clouds, 32% of the time. Scattered, 3.9% of the time. Today it's scattered. Broken, which means over 50% overcast, about 29% overcast, 20%. So these two together, like 48, 49%, which is what they say here, 48 or 49%. But what they didn't do, they didn't break these statistics out by time of day. Because early in the morning, a lot of times, it's overcast and it burns off. So I think it's a little misleading. I'd say we probably, according to this, we have a 50-50 chance of it being too cloudy to see the eclipse, but I think we're probably going to do a little bit better than that. My hunch is. I just don't think of August like I think of November. And so, you know, I think we'll be doing a little bit better than that. But what you want to do is to take a look at the weather and see if you can spot a place. Okay? Yeah, okay. And see if you can spot a place where it looks like it's going to be clear, that's within driving distance, and on the route here. So that means you would either drive, you know, to the southeast or back off to the northwest. It goes right over St. Joe. So if it looked like it was going to be clear, you could get up like the day before or early in the morning, drive to St. Joe. And it goes pretty close here to Boonville, and just north of Jeff City, here's Columbia. I mean, it's just passing right through the heart of Missouri. Okay? You need to be there. The moon's shadow moves very quickly. It moves over 1,000 miles an hour from the northeast down to the southeast. Okay? And so the eclipse here starts like 13 minutes before it starts for us. So you need to be there about the same time. Okay? If you're gonna travel. And it is worth traveling to see this thing. I will tell you that. It is worth going some distance to try to find a place where it's going to be clear. But let's hope that you know, we get a break and that the eclipse will be right in our area for us. So that's the first thing. Find a spot. Secondly, find a spot where you can see the horizon all the way around. I mean, if you want to stay home and look at the eclipse, it's going to be clear, you're just going to stay home. Okay. Well, if you have trees all around your yard, you're going to miss out on some of the things. If you get up where you can see the horizon, you'll be able to see the shadow of the moon coming toward you. Okay? So if you get up where you can see the horizon, you'll see this dark wedge getting bigger, bigger, and bigger coming from the northwest as the shadow comes on. Okay? And so I always thought that was, that's kind of a fun thing to see. But you need to be where you, and also you won't be able to see the fact that you get a sunset all the way around the horizon if you can't see the horizon. So do that. Protect your eyes until it's totality. You cannot look at the sun with your naked eye, the surface of the sun, even the smallest piece of the surface of the sun. So keep the eclipse glasses on, or you can use a projection method, okay? Or you can use a pinhole camera. Something where you don't look directly at the sun, and all you're really looking at is to see how big that crescent of the sun is. So you're not going to see anything different than that looking through these glasses. Okay. You can't use sunglasses to do that. You will go blind. Don't use sunglasses on this. You've got to have these special glasses. They're actually mirrored. You see that? They reflect away. They're a special kind of mirror that lets you just a tiny bit of the light in. So like a welder's glass. You might be able to use welder's glasses, but these things they've already tested and so forth. So you have to protect your eyes. Don't ever look at the sun through anything like a pair of binoculars or a telescope without having a solar filter on the thing. You'll go blind. Okay. Galileo went blind looking at the sun through his telescope. He died blind because he had blinded himself trying to look at the sun. So protect your eyes and then once totality happens, once that nighttime comes on, take them off and look at the sun, through your naked eye. Okay? And then I said again, don't take any pictures during totality and try not to bug each other. We're probably going to have our grandkids with us. That's really mostly for Chris and me. That advice is. But we'll have the grandkids around, so we'll see how much of the eclipse we actually see. Okay, did y'all have any questions or anything? Well, we're looking at a place up in Festus, so we may head up there. But we're going to try to find a place where it looks like it's going to be clear. If we have to drive to get there, we're going to have a bunch of family down there. So that's where we're going to go. Mac's not a bad spot, and you really you get almost the full totality. I think in less than 20 seconds of it. So this would be a pretty good spot. Karen? Other questions? Oh, yes, ma'am.
Could you feel any sort of temperature difference or change as the eclipse happened?
Well, it's like stepping into deep shade on a summer day. Okay. It's just the weather gets cool. Sometimes the wind starts blowing around a little bit because of the convection and so forth. But there'll be a temperature drop. You'll notice the temperature fall. Yes, ma'am.
I have a question from a student. They would like to know the difference in how we would look at the sun on a normal day and on an eclipse day. Is it more dangerous before totality than it is normally?
No. The sun is just as dangerous today as it is as it's going to be on eclipse day. You don't want to look at the sun through any kind of, you don't want to look at the sun with your naked eye, period. And most people, just common sense, you can't stand to look at it. But since so many people are focused on the sun when there's an eclipse around, people are afraid that they're just going to be staring at the sun. So just don't do it, okay? Did that answer that question, do you think?
Yes.
Okay. All right. Other questions? Okay. One that was asked, my wife was interested in, was why is the shadow moving from the northeast to the northwest to the southeast? Why is it, everything else rises in the east and goes sets in the west? So why is that? Well, if we look at our little map here of the moon is moving the same direction as the Earth rotates. This in orbit. Okay? And so it takes 28 days for the moon to make the loop around the Earth. So from here to straight overhead, it's going to take it 7 days, right, to go from new moon to quarter. The moon straight overhead is quarter moon. When it gets over here, it's full moon, another quarter here, then back to new moon, right? All right, so if it's 28 days to make the whole loop, it's going to do this quarter loop in 7 days. And I do that because you can kind of visualize, okay, what's a seventh of this thing? Well, it's like here, here. That's how far it's going to travel in 1 day in its orbit. Okay. The velocity of the moon is a little over 2,000 miles an hour. The velocity of the moon's shadow moving from there to there, it will pass in this direction at about 2,000 miles an hour. at the equator, the velocity of someone on the equator rotating around the Earth is about 1,000 miles an hour. Okay, and up here it's even less because we're going around a smaller circle in 24 hours. They're on the line of latitude, right? So the moon is going to pass us at about 1,000 miles an hour, and that's what happens. That's why it starts in St. Joe. It is hauling it across the Earth, the moon's shadow it, much faster than the moon is rotating around in its daily thing. So the moon passes, eclipses pass from the west to the east.
When was the last time it came this close to this end in terms of that?
What was it, like 1400 and something?
And I read.
It's like before Columbus? Before
Really?
Columbus.
So this is a big occasion for this area.
For this area here,
Because when you look at the other ones, it goes north, south, and a lot of the ocean. But
yes.
so has there been any spectacular things that has happened historically with the solar eclipse around here?
Oh, yeah, of course, there were a lot of virgins killed way back when, to try to get the demons away from the sun. And empirically, it always worked. So, that was bad news for the next person. It worked last time, they're up here. So, that of course, and anything that would appear in the sky like this, the rulers in the ancient times would take as signs. They were always after some sort of predictability. And so they had their wise men were actually creating databases of observations. So things like comets and eclipses of the sun and the moon, a lot of those things were written down. The Chinese wrote them down, the Syrians were writing all this stuff, hoping that they could find some pattern to this. And the ancients actually knew the cycle of solar eclipses. Stonehenge did. There's some of the ways that it's a big counting, abacus kind of thing for lunar and solar eclipses. At least that's what we determined by applying some computations to the way they laid that place out.
It's pretty amazing.
It is amazing because the distance between solar eclipses for an area like ours is much longer than the human lifespan. So how those guys write that down and pass it on to the next generation, so that they would say, oh, wait a minute, there was an eclipse so many thousand days ago. We got to put a rock out there or something. How did they do that? That's a big mystery. I think they were smarter, our ancestors, than we give them.
The other thing is, I've been finding out the Aztecs, indeed, they're looking at South American monuments and things, the pyramids, and finding more and more connections, perhaps with the solar eclipse.
Well, that could be. I mean, they do line up on cardinal directions for things in the sky. And I think a lot of that was because, for several reasons. One, they had dark skies all the time. The ancient observatories were set up on palace rooftops, right in the middle of town. Well, they didn't have street lights. They had nothing else to do at night. There was no MTV. So they would just sit out and look at things, and they would watch what happened in the sky. And the planets and the moon were regular. They could watch those things. Jupiter moves from one zodiac constellation to the next every single year. And so they watched all of these things. And that was the one thing in their life that they knew was going to happen. It was predictable. And so that was an important thing to them. And they would lay their cities out to watch for these cardinal events to happen, like the coming of spring and so forth. And so to the ancients, the sky was much more important. In our time, you live in even a small town, you can't see the sky when you go out at night except for a handful of bright stars. So I'm glad that people are now trying to install dark sky lighting in towns. There are like 13 parts of the United States that have been designated as dark skies, so you can go and you can see the sky the way the ancient people saw it. And when you finally get out in a dark sky, let your eyes adapt, sit out there and wait about 30 minutes in the dark, and go take a look. I think you'd be astonished at what you see. It's just breathtaking. Yes, ma'am.
We have a question relating to lights. Will the cities turn off street lights for the solar eclipse? Or will
We won't need to. The solar eclipse will be in the middle of the day, and the street lights will probably come on. That'll be another effect. I didn't have that in here. But the street lights will probably come on in these towns because it'll be dark. But I don't think they'll do anything. They'll just let it go.
will that affect the viewing?
Yeah. No, it shouldn't at all.
Okay.
Anything else? Other questions? Okay.
Okay.
saw another total eclipse. What was that like for you? I mean, was that,
Well, we did what I'm telling you to do. I was living in Huntsville, Alabama at the time, and we knew the eclipse was coming. I was working at the Marshall Space Flight Center, so there were a bunch of us, of course, that were interested in it. We were a bunch of nerds, geeks, dweebs, and so we wanted to go see the eclipse. And it was cloudy everywhere where we were, but there was a place that was clear over in South Carolina, and the eclipse path was going right over it. And I knew how to fly airplanes, and so we all jumped in an airplane, we flew over there, got to the airport, and the eclipse was just like I told you. I mean, it was just breathtaking. I didn't know what to expect. I'd seen pictures, and it looked like blowing cloud around a black hole. But when I was there, and just the presence of it, and to actually see that thing right in front of you, it was really something. I thought, I've got to see another one of these. The guy at the airport, we told him when we flew in what we were doing. Because other people were flying into that little airport too. And he came out, he dismissed the whole thing. It was just folks, and then it got dark. And he came running out. And he was expletives going full blast. That's what I remember about that eclipse. Well, I'll be. Then the eclipse was over and we all jumped in the airplanes and went home. But that's what it was like. Other questions? Usually I get asked about why do things orbit and stuff like that.